for having me. I'm very stoked to be here and really appreciate the chance to talk about this stuff. This is my favorite topic by far. I love talking about building web apps. I love how the art has changed and modified over the years and how it's grown. The original title for this was Functional Web Apps, The Revenge of Dynamic Apps. But in the process of writing this talk, I realized there's no vengeance. This is just the future of something we're already doing. So with that, we'll start digging in. Oh, a little bit about me. We've already said all these things, so I don't need to reiterate them too hard. I've been doing web development for a very, very long time. And if you rant at me, you can find me in these places. So before we get into what a functional web app is, let's talk about what a dynamic web app is. The first consideration is a dynamic web app is not static. It's rendered on demand. And it's not just HTML that gets rendered on demand. It's also JSON. And we do this all the time. Every API that gets built out there is probably a dynamic app. It's going to be talking to a database. It'll be full stack. It'll return data immediately. And this doesn't mean it can't participate in things like caching. This is CDNs were originally for this use case. So this is something we're still doing, very common. And typically we call this a 3-tier architecture. The reason we call it a 3-tier architecture is we're breaking up our concerns into 3 different parts. Sometimes people call this MVC for model view controller. I like talking about it in terms of presentation logic, application logic, and data access logic. The presentation is your view code. You want to have that separate from your application or your business logic, because in theory, the business isn't going to change as much as the UI. And then your data access layer is going to hide your database internals from your business logic layers implementation. So if you have an entity, for example, shopping cart would be a good one. Shopping cart might be a table, and it might have like another table called shopping cart items or something. Inside your business logic layer, you want to have a completely shopping cart centric experience. You don't want to be querying and joining tables and stuff. So that's why we separate those concerns. And the traditional dynamic app ecosystem is huge. Any runtime or popular language or library place is going to have one of these. I like talking about Rails in this world specifically because Rails is probably the cleanest implementation of MVC out there. It's literally MVC. So they have a action view is their presentation layer, their view layer, action controller or the routing layer is their controller layer, and active record is their database access layer, their data layer. And that's a logical architecture. So this is how we organize the code on our disk and in our source code. The physical architecture of deploying a 3-tier application turns out to be a little different than the reality in your source code. And this is probably actually a very generous way of looking at it. If you've built one of these before in the past, there's a few more boxes and a few more arrows, but this is roughly what ends up happening. We'll load balance a suite of web servers so that we can handle the traffic that they get. And they'll typically be talking to a database server and a caching server of some kind to keep things fast. All points of this themselves can scale horizontally too. And where this got kind of messed up is when we were deploying, because our logical architecture is really only going into one of these web servers, and then we repeat it for every web server. And if we're taking on more and more traffic, we're going to have more and more web servers, which means that we're going to have more and more places to deploy to. And if something goes wrong, we'll have to roll back each one of these web servers one by one. And so that's a big problem. The other big problem in here, there's lots of stuff that isn't in version control. And so originally, places like Heroku sort of said, hey, we'll take care of that part for you. It's sort of infrastructure as no code. You write your application in a certain way, and all these other magic parts will happen for you. Over time, that didn't really scale. And so tools like Ansible, Puppet, Chef came around, and they were called configuration management tools at that time. And those would let us check in some kind of manifest or artifact that would describe the infrastructure dependencies we had. Eventually, that evolved into a concept we call infrastructure as code, where we're declaring our dependencies the same way we declare our code dependencies in package JSON. We would declare our cloud dependencies in something like Terraform or CloudFormation. And that way, every time we deploy, we get the thing we want. We're not having to like wonder about how these things get provisioned or how we reproduce this environment when we deploy. So, I mean, like that's a whole bunch of problems, right? Like We got this 3-tier logical architecture. It has nothing to do with the physical architecture. So this makes deploying hard. Stuff's not versioned, slow. It's kind of difficult to scale horizontally. HTML from traditional databases rendering can be slow. It's not always slow, but it can be. Maintenance cost is huge. Each one of those servers needs to be patched. You have to update it. You have to debug it when things go wrong. Not if things go wrong, when things go wrong. And that's always been the trick. The other part about this is there's a lot of tasks that have to happen in the background when you're building these types of applications. You're going to need primitives for doing queuing, eventing like PubSub or cron tasks that run on a regular schedule. And none of these 3-tier architectures really take that into account. And so you end up bolting this stuff on the side and it gets kind of clunky. And this is where the JAMstack came in. And the idea here is that we're going to build a totally static artifact by pre-rendering everything. And then we serve it via CDN. And any JavaScript or any dynamic functionality is going to be done by JavaScript at runtime, which is great because we all love JavaScript. And it's kind of cool because the deployment is immutable. Nothing's really changing. We're just going to mash all our code into this one artifact, and it's going to be the same everywhere. And this is also great because we get to outsource undifferentiated heavy lifting to a provider that does something that we maybe don't do as a unique offering for our business. A typical example would be like Auth0 for my authentication. I don't want to handle that. Someone else should. Auth0 does that for a job. So we can just outsource as much of that dynamic functionality as possible. And that comes out to be a pretty clean architecture. In fact, if you look at this closely, you'll notice it's a 2-tier architecture, which is really interesting because that was the original kind of architecture, client server. Put all of our logic in the client, and then we talk to servers for our data. So that's pretty cool. The JAMstack physical architecture turns out to be a little bit different, but pretty close. So we end up mixing our presentation and our business logic in one artifact, and that goes to the client. And then we use the network to talk to these other services for our backend. And that's okay. We are just deploying this part here, which means that these parts aren't in our version control or in our control. So that's a little bit problematic. We might have seen that story before in early Rails. So these are just trade-offs. This isn't a judgment of good or bad. This might be fine in your case. So I'm not admonishing anyone. We build this way sometimes ourselves, but first problem is you'll have slow builds, and the builds are not going to get faster. As you add more code, the build gets slower. And so if you're starting off with hello world and it's kind of quick, that's great. If you add 1,000 pages, stuff gets slower. There's not much you can do about that because more code is just going to take longer to compile that one artifact. The bigger issue for me is that you end up having dynamic functionality hide behind a spinner. So anytime we got to do something dynamically or personalize the experience for anyone, it's going to be a second-class citizen to that initial load. And so that's a bit problematic. The final sort of problem is that a lot of this stuff is being glued together in an ad hoc fashion. There isn't one single distribution of the system that we're building, and there's asymmetry between the code and the infrastructure it depends on. We're outsourcing a whole bunch of work, which is great, but we're still responsible for it. Our customers aren't going to call Auth0 if something went wrong. They're going to call us. So that's just worth noting. They're just trade-offs. So the functional web app is a different approach to this idea. It's HTML first, which is saying that we will do dynamic personalization with progressive enhancement, making accessibility the priority. It's a cloud function centric model, which is a way of saying that the entire system is composed of pure functions from front end to back end, the whole entire thing. This is nice because now your whole system is full stack. You can do everything that functions can do, which is most things. Another component of this is databases are on demand now. We don't need to deploy RDS instances. If we don't want to, we can auto scale. We can guarantee millisecond latency. And that's pretty nice. So we don't have the database bottleneck. And then sort of the final thing is declarative deployment, where we're using infrastructure as code to explicitly define what our cloud infrastructure resources are when we deploy them. So the logical architecture of what I just described looks like this. We're putting our view and our controller logic in cloud functions, and they're talking to a data access layer. The physical architecture of a functional web app comes out very similar. There's a high degree of symmetry. There's still CDN, there's still static assets, We can still babble our webpacks if we want to, but you probably don't need to. And all this functionality can scale out horizontally beside it and talk to a managed database. And the real beauty is your deployment is the entire thing. So you get one declarative, fully deterministic artifact, which is really nice. So, if you look at these side by side, you can see which parts are being deployed, which parts are talking to a database. You're just going to get a better initial experience with this kind of architecture. Functional web app has a few key advantages. So the first big advantage is this is more powerful. You have the full stack available to you and it's all in one place. The second thing that I think is the most important is it's more fun. I believed Rails when they said it would make me happier, and I was happier writing Rails, but it wasn't fun. And when we're building applications and focused on unique business logic and not maintaining a bunch of dependencies all over the place, it turns out to be way more fun. You're just moving faster and you're shipping. You're not treading water, trying to keep things up to date. You're not dealing with breaking changes. You're not dealing with unplanned work due to breaking changes. You're just shipping. And the final bit here, probably the most important part to me, truly, is that this is an inclusive, fast, accessible web consumer experience by default. We're not going to hide dynamic content behind the spinner that may or may not load. When I'm talking about this architecture to people, I get a few common sort of points brought up. And so I want to address those out the gate. First one's always cold start. What about cold start? Cloud Functions, we've known this since 2015 or so, correlate to, or the cold start correlates to payload size. The bigger the Cloud Function, longer it takes to start up. And so the solution to cold start is to write small functions, small single responsibility functions. You really don't want to have more than 5 megabytes in a Lambda function. It'll keep it sub-second, and usually it'll actually load in around 200 milliseconds, which is completely acceptable performance. If you have cold starts going over a second, your Lambda function is probably just too big. If that doesn't help, you can pre-provision capacity. That's kind of defeating the purpose of being stateless and on demand. So there are solutions for this, and chances are the problem is self-inflicted if you have a cold start. The database story is still emergent. There are only a handful of on-demand auto-scaling databases. I'm going to have to modify this slide. I forgot to put FaunaDB in here, which is bad because they were just give a great presentation. But Fauna, Dynamo, Cosmos, PlanetScale, these are all great options. They're all guaranteeing great performance no matter how many rows they have. They're all multi-tenant. You don't have to think about your data layer anymore. And I don't want to, I just want to write it. Declarative infrastructure as code can be accused of being complex. I fully agree with that assertion. I think CloudFormation is a bit of a nightmare to write. We've written our own declarative infrastructure as code thing called arc.codes, where we get the complexity really bit back to a tenth of what you would see with CloudFormation, sometimes even better. The last point is salient, and it's important. If you're going to go all in with a Cloud Functions provider, that means you're kind of going all in with that provider. These things are not very portable yet. The standards are still new. An Azure function is not a Firebase function, is not a Lambda function, it's not a Cloudflare function. And so, maybe that's bad. If your primary goal is to be portable, you may want to consider running your workloads on Kubernetes and deploying Rails instead. If you want to jump into the future here, though, this is definitely the way to go, and it will require you to pick a vendor and go with them. So choose wisely. For my money, Amazon's pretty good. They appear to be around for a while, seem to know what they're doing, good SLAs. So I'm not really worried about them disappearing or raising prices or pulling the rug on me with breaking changes. Those are things that will not happen. So I don't think it's a very rational argument to say it's bad to lock into a vendor. This is a growing ecosystem and it's new, but there are probably hundreds of providers, if I'm being really honest. These are the ones that we hear about all the time. If I'm missing someone, let me know, but there's lots of ways to go about doing this kind of architecture. The big key is that we're starting with Cloud Functions and we're progressive enhancing on-demand HTML. It's not just me saying this either. This is happening all over the place. These are links I will be sharing this presentation so you can check this stuff out. Whoops. Hey. BBC's built this way. CloudGuru is kind of built this way. They're pretty interesting. They just had a huge exit. Bustle magazine's built this way. Begin.com is built this way. So it's very doable with huge workloads and quite fun. So the static app thing has been great. I love it. I think it's fine for inert content, but as soon as you're starting to go dynamic, it's time to take a look at this type of architecture. I believe personally that we should be looking more closely at HTML first and progressive enhancement for the most accessible experience. I think a cloud function centric model is well overdue. I think managed databases have proven themselves to be very good and useful. And infrastructure as code is just table stakes to me if you're working with the cloud at this point. So these are the key points and practices. If you want to try this out, you know, pick your providers and give it a hack. And I would love to talk about it if you do. I work on an open source project called Architect. You can find that on GitHub. We deploy Architect apps at begin.com, so check that out. And yeah, follow me and rant at me if you'd like on the Twitters. Oh, that went really fast. That was it.
Thanks, Brian. I'm waiting for the screen to update. Now I see Brian twice. There we go. Oh, wait, now you see Brian twice anyway. Before I saw you twice, now it's still two Brians, but
can't have enough Brians.
This is true, unless it's with a Y. No Brians with a Y allowed. Sorry.
Well, those ones are evil, I've heard.
Oh, that was really interesting. So you know, I will admit, like, as you know, you and I have chatted before. Like, I've been in the JAMstack space for a while. So, you know, I think my feeling was like some of the difficulties you mentioned are legitimate. You know, I know, like, for instance, we were talking about build times in the chat here, and build times, I mean, it's one of those issues that is so glaring in a way, as JAMstack has expanded out beyond, like, say, just your kind of hobbyist audience and things like that, to like really big companies building, you know, enormous sites, that it's become such an issue that, like, we have now competing solutions out there trying to fix this, you know, the incremental builds and DPR, which is Netlify's thing, and ISR, which is Next.js.
Distributed static render and incremental static render. Yeah.
So, you know, I mean, I think that's legit. But I guess I'm curious, like, so can you give me like a brief, the difference between like building, am I still, say, using Next.js, or how am I building the front end? Is it like completely different?
I think that's up to you. I mean, I don't know that Next.js is capable of progressive enhancement, but I imagine React is. And I don't think it's an either or, right? Like, if you're building an API, you're not pre-rendering anything. So, you know, very large portion of your functionality is already being built this way. Even if you want to just still pre-render your whole front end and all your presentation and business logic into one thing, that's fine. What I'm advocating for, though, is like we should start considering that a lot of the solution that we have right now are for problems we no longer have. So the JAMstack approach is good. It works. It's great, especially for inert content. But for personalized content, it's not very good. And it's okay to say that. And we can do better. And I think from an accessibility standpoint, we have a responsibility to do better. We're all pretty much in agreement out there that the web is not improving so much as we thought it might. Payloads are getting bigger. Accessibility is not the primary concern that it used to be. So, like, yeah, the developer experience is getting worse. We're going slower and slower builds. But even more important than that, the accessibility of our sites is not as good as it could be. Being greeted with 10 spinners while Suspense renders itself out is not preferable to getting the experience that you could get immediately with HTML first. And it's not just one way of doing things. I mean, Astro is a new static site generator that's sort of pushing this idea of progressive enhancement and islands architecture. Similar thing. I'm just looking at it and compute's dropping to 0, cold start's dropping to 0. Why am I running a build? What is that getting me exactly? It's getting me an artifact that has no relationship to the way it's being deployed. So that's a thing.
Right.
And it's okay. Like, I'm not saying there's one way to do things. I'm suggesting though that there are other ways, and that we should explore those.
And so in this case, like my serverless function is returning, like, is it kind of like at some point it's returning HTML back and then hydrating?
Yeah.
That's what we're, so instead of like basically being an API returning JSON and then we're doing this on the front end, we're doing it on the server and then pushing that up.
Yeah, and even React's moving this way with its server components, and I'm glad it is. You know, I think that's how it should work. We don't have to have perfect symmetry necessarily between client and server components. The server doesn't have click events or load events or touch events. The server does have data, and it could load that initial render a lot faster. And you know, we've been doing this for a very long time. Lots of application architectures still do this to this day. GitHub.com, for example, is a progressively enhanced application. So why not take those ideas now and apply that to Cloud Functions? Is kind of the question I'm putting forward with evidence and other people who are already doing it. So
that makes sense.
It's yeah, and it's not an either or. I think a lot of apps are going to have a lot of static content.
Right.
You know what? You should use a static generator for that stuff. If it has a lot of dynamic content, like imagine if GitHub was pre-rendered, it wouldn't make much sense. You would just have spinorama everywhere.
No, yeah.
And that's okay. So it's not an either or, it's more of like a use case specific thing. If you're building something dynamic, you should probably consider, you know, an HTML first progressive enhancement kind of thing. Argument against that would be, well, servers are slow or whatever. And good news, we don't need servers anymore, so it's fine.
Yeah, that makes sense.
You know, databases are slow. Well, good news, they're not anymore. In DynamoDB, we can get 300 megabytes of throughput per second in the free tier. So I mean,
right.
It's the future is here. It's just not evenly distributed yet.
Yeah, I mean, you know, and I've toyed with some ideas around this, and I guess I haven't really dug into it enough. You know, because one of the things I still think, you know, a lot of content ends up being like, it doesn't change that often, honestly. And in those cases, I think you would pre-render that regardless. Like, there's no point in hydrating the contents of a you know, blog post or an about page or, you know, any of this stuff, right?
Doc site.
Yeah,
totally.
Yeah. So I mean, a lot of the web still ends up being kind of, but I do feel like I toyed with you know, like say something like a Cloudflare functions can then alter, you know, at the edge, right? Like I can actually add your login information, your personalized information. I'll handle that in a Cloudflare function that's run at the edge that so you don't even notice any difference, right? Like as far as you're concerned, this didn't wait to the client to get loaded in. It got loaded in before it ever hit you. Is that kind of consistent with this?
Can talk to, totally, yeah. So like a Cloudflare function talking to durable objects, is that what they call them?
Yeah, I don't know.
Objects, I can't remember. Anyway, so they have a database solution or a key value store. They have a functions solution. I don't think they have an infrastructure as code solution, but I know Terraform supports them. So you could build a functional web app that way. You know, you could use your Terraform to deploy your edge functions that talk to their edge database and off to the races.
Right.
And depending on the use case, that might make a lot of sense, especially if it's like, you know, layering in a shopping cart on top of your statically rendered shopping website. That would be a great use case. And it doesn't have to be an either or. You know, the CDN is probably going to sit in front of any of these things anyhow, so we can tune it. And the CDN it's almost more powerful with a Cloud Function because we can set the headers on the way out, so we can give the cacher, you know, some kind of intelligence if we wanted to, instead of just caching things forever.
Right. You know, and I only brought up Cloudflare functions in particular because I think when I've toyed with AWS, it doesn't actually allow you to modify the DOM, if I remember, on the way back.
It depends. They have a few ways of playing with the DOM. Their new CloudFront functions can't. They can only modify headers.
Right.
Lambda at Edge, you could write a whole, DOM thing you want. The Lambda at Edge is running the Lambda function at one of the points, one of the CloudFront points of presence, which is supposed to be faster. If you have a function in a region and then it's behind a CDN, that's still going to be really fast. We're talking hundreds of milliseconds difference, and I don't think in many of these static apps we're building a real-time MMO, so like 100 milliseconds isn't really going to matter that much. But I see that it isn't 4 or 5 milliseconds, which you can see right at the edge.
Right.
As a human, I don't see, think, or read that fast personally, but pick your poison, I guess. And this is also the good news. There are lots of ways to do this. This isn't like a particular vendor. If you're in the Azure ecosystem, there are very good options now there. If you're in the AWS ecosystem, obviously they're the market leader. Cloudflare's turning the gears on all these guys, and they're kind of like a niche player who's really kind of leading the product charge in a lot of this thinking. And there's outliers coming up now too. Deno deploy. I would be remiss not to mention that, which is like Cloudflare Workers, except for it's the new Deno runtime. That is extremely compelling to me because it's basically a browser that runs in your terminal. So this dream of having this code that runs both in my browser and in my back end is rapidly coming true. And I think there's going to be a whole variety of these things. Like, we're not going to see a consolidation down to one runtime. There's going to be a bunch of these things before there's a few of these things. And that diversity is a strength. People can choose the providers that make sense for them and build the app that best works for them.
Yeah.
Just to highlight this and underscore it, the first thing that's most important is we got to get back to accessibility and back to rendering HTML first. Like, this client render spinorama thing it's not cool.
Yeah, and actually getting to the questions from our audience here, one of them was on accessibility. Nick says, in terms of accessibility and making it progressive in the context of JAMstack, would you use a serverless function for a normal form post, JS disabled? Yeah. If so, how does that work since it's JAMstack and you can't really do a full round trip with a page refresh? So I'm not sure. Does that make sense to you?
No, but I'm in the AWS ecosystem, so let me tell you how I would do this. I would set up an endpoint behind API gateway that responds to a post, and that's how I would do that. And it can come back to the client. I don't know. I thought Netlify supported all the verbs. It should. If it doesn't,
they do.
I would assume you could post to your own function. I know that they give you weird URLs, so you're not provisioning with Infra's code, so you get these compiled out URLs that are kind of strange, but you could use redirects, .toml, I think it is, to remap these back to human readable things. And I acknowledge a lot of the current generation tools have lost the plot a little bit and aren't really designed for progressive enhancement at the gate. That is a fact. And I think once you get into doing progressive enhancement, you'll quickly realize that it was a lot easier to do a form post and a redirect than it was to try and build all that logic into your client. And you can still build all that logic into your client. This isn't a mutually exclusive situation. In fact, this is a more resilient one. So JavaScript's going to fail. There's an accessibility argument, but fuck that. Let's just talk about like when your JavaScript fails, because it's going to fail. Mm-hmm. When it fails, if you're relying on client render, that's it. Game over. Your user experience is done. If you progressive enhance, your whole app works. And then if the JavaScript works, cool. You just took over the experience and you can do whatever behavior client side that you want. So it's not an either or, it's an and also. Whereas if you go fully client side render route, then it is mutually exclusive. You've opted to have a less accessible experience.
Right. Okay, that makes sense. So Nick also asks, I've never used arc.codes, but curious what the differentiating factor is from other competitors. Is it DX or more than that?
Well, the first thing is it works locally. So for us, that was really key for our iteration speed. So anything you can do with Arc, you can do it locally. So you don't need to deploy to Amazon or have an AWS account to give it a try. Architect is designed for building web apps, where a lot of serverless stuff that's out there has been designed for building for the cloud. And there's a lot of use cases for the cloud that have nothing to do with web apps. So if you're building a web app, you're going to want things like middleware and session and blanking, like eventing needs to be built in first class. It can't be something that's kind of on the side. You're going to want to have access to, the key primitives that you're going to need to build that web app, which is going to be static assets, cloud functions, and some kind of managed database deployed by infrastructure as code. And that's really what Architect is. And you can do a lot of this stuff with other tools, but because they're not designed for the use case of a web app, you're not going to have a local development experience, and you're not going to have these affordances for web developers like session and stuff built in necessarily.
Cool. Yeah, I remember, that reminds me, about 4 years ago, you came and spoke about Architect on CFE.
I did, yeah.
Yeah.
This has been a long journey. Back then, serverless was crazy.
Yeah, I know. Things change quick. So Paul asks, if you're trying to create a web app running from scratch today, let's say it starts off as a forum, calls external APIs for topics, you can create forum threads from. What new solution would be fun for you to try out? Okay, I guess he's just looking for ideas on to help him build out his forum, or.
Yeah, so, well, I mean, I always like to take these types of things for a spin with a CRUD app. My classic is, right now we're working really hard on trying to figure out how to do server render for web components. And so our first stab at this was to build like just a single page app. And it worked, it was great. We were really excited. And we're like, well, I guess we're gonna have to try and talk to some data now with this thing. So we built a CRUD app on top of that. And we learned a whole bunch about like web components in that process, because a CRUD app's really gonna show where the seams are. So we built like a to-do list type of thing. And then we were like, well, okay, we got web components figured out. We got the rendering client and server, that's great. But a lot of what we do in our app is WebSocket based. And so we're streaming events and then we're rendering the UI based on those events. And so we've been experimenting by building something that does that. And it's changed our perspective a fair bit, but mostly on the data management side. And so this is a bit of a rambly answer, but I think you want to pick use cases that are going to really exercise the types of functionality that you want to try and achieve. If you're building a contact form, I have no idea why you're using React. Just post and write that to a database. Like users don't care. But if you're building an interactive space war game that's rendering mostly the canvas, then yeah, WebSockets are going to be a thing for that. And how are you going to orchestrate the data events between those things? Those are entirely separate use cases. So it's worth giving yourself some tough problems to work through. HTML forms are really powerful, and I think they're underappreciated for what they allow you to do. So yeah, I would just build something, man.
Sometimes. Yeah, I agree with you. And
see how it goes.
on that note, the other day I saw an article that had me really dismayed. It was talking about taking your static HTML and converting it to a React app, and I'm like, but why?
I mean, maybe there's a good, like, if you're, you need interactivity.
I guess if you want to learn React, I'm just like, but I do think some of the basics just work, and I'm not dissing React. I feel like we just have lost that differentiation between when it's a good idea and when it's not a good idea. It just becomes like, oh, I'm starting a site. Let me bring all this in.
Yeah. And not to like dogpile that idea too much, but like some of the new stuff that I've been playing around with seems a little better for reactivity, and in particular Svelte. It's really nice. And like the programming model for Svelte is really fun. They've thought of things like animation and transitions as first class into the framework. And if you do have one of those UIs that needs to do, heavy transitions and animations and a lot of client interactivity, yeah, like build it that way. But if you're building a form, blog, doc site, or landing page, you probably don't even need JavaScript. And why opt into work? We all want to go home at 5. And we don't want to spin our tires maintaining a TypeScript config for something that has no client interactivity. It doesn't make any sense at all.
Yeah.
So it's a choose your battles kind of thing.
Yep, absolutely. Well, this was a really, really fun conversation. I'm curious to try this out, your kind of concept of this, and see how this works in like, actually building something with it. So thank you for kind of inspiring me there, and hopefully everybody else in the audience was inspired too to go give this idea a try. So thanks for coming out, Brian.
Thanks for having me. And yeah, let me know how functional web app building goes for you, man. I'd love to hear all the good, bad, and ugly.